Hello, and welcome to C++ for Beginners, Introduction to Classes. In this sixth video of the C++ for Beginners series, we will be covering classes. A class is a user-defined data type. Unlike the data types we have worked with so far, such as ints and strings, a class allows us to build a structure that more closely mimics the real world. A class is also a building block, which will lead us to object-oriented programming in C++. Before we get into classes, however, let's look at an older data type, a structure. A structure originated in the C programming language, and in C it had a lot more limitations than the modern C++ version of structure. Just to briefly show a C-style structure, let's look at this example. Up on top I have a brief description and basic outline for a structure. We use the keyword struct and give it a name, in this case, myStruct. Inside the structure body itself, there are three variables, also called members or data members of the structure. So now here's an actual demo structure we can use to demonstrate its basic functionality. Again, we have the struct keyword, the name, myStruct, and I've assigned it three variables, an integer a, integer b, and a float f. Also note that the body of the structure is enclosed in curly braces, as we've seen before. However, with a structure, and this also goes for classes that we'll be discussing soon, you have to terminate it with a semicolon. I will show the reason for this shortly. Down in main, we need to declare a variable for our structure. Struct, keyword, myStruct, referencing our structure frame up here, and an object named s. You can think of this as sort of a variable that we're assigning to our data type, myStructure. Much like when we declare a normal variable, such as int a, we need to do the same for our structure. Remember that since the structure is a user-defined data type, we can't use it directly, so instead we create a variable, or an object. To do this, we use struct keyword again. Our structure's name is myStruct, and our variable name or object is named s. So this may be a bit confusing at first, but it's basically saying I want to use a user-defined data type named myStruct that is a structure and name it s. Here in the same line, we're just assigning the initial values to the internal data members of the structure. Note that they're contiguous, which means the first value will go to the first variable, and so on. So here we're assigning 1 to a, 2 to b, and 4.2, a floating point value, to float f. Here I have a C-style output statement. This is not a lesson in C, but just quickly so you can understand, we have printf, or print format, which is a function. We then give it a string, and format specifiers, which are these with the $d. It's pretty much $d for integers, $f for floats. There's also other identifiers such as $s for string, which we'll use shortly. Notice also that we can use a character such as the new line sequence. The rest of this is pretty much just the text string. So we'll basically have new line, we'll print out a equals, let's substitute in our first integer that we're assigned back here. Give us a new line, b equals, assign our second integer, which we get from here. New line, and finally f equals in our floating point number, which is obtained from here. Notice that we're accessing our new object using the dot operator. So we got our object name, dot, and the member variable that we wish to access. So in this case we're accessing a, in this case we're accessing b, and finally f. So moving on, let's compile and run the program to see the results. Here we can see the output matches our data members as we specified them. A is assigned 1, B is assigned 2, F is assigned 4.2, and notice in C it formats the floating point numbers a little bit differently. And just to be clear on this point, I want to emphasize that we're using the object S of my structure. We're not accessing the my structure itself. To illustrate this, I'll create a new object. I'll call it S2. And I'll assign it some variables right away that are different. And I'll just copy paste the output. And we'll set these to S2. Go ahead, compile, run. As you can see, now we have two instances of the my struct returning different values. The first one we created with an object called S and assigned it these values. Second one we created an object called S2 and assigned it those values. So I just want to emphasize that we're actually creating objects of the my structure data type. We're not referencing the my struct itself. Okay, now I also want to demonstrate we can use character types as well. So we're not just limited to numbers. We make a character C. Since this is the C programming language, we need to declare like an array of characters. Don't worry about it for now, it's just for the demonstration purposes. But this character C, it acts like a string and be able to hold up to 30 elements. And we'll also have to modify our output strings. Let me just get rid of the S2 stuff for now so it's not confusing. So we'll just go into our output string here. Add a new line character. Character C equals, and this time we use %s for string. We'll also have to add the input parameter. So again, we're using object S. This time we want the character C. And we'll also have to feed it a parameter. Alright, let's compile and run. And here you can see the added result. So I've gone ahead and added 2 more lines of code to show that we can also work with the variables in our structure. We don't have to just rely on initializing them when we declare it. So here I'm going to change the value of f in our object S to basically pi, the value of pi. I'm also going to change our string from my string to designated initializers. Let's compile and run it. And as you can see, our changes took effect. And before we move on, I just want to cover one more thing, and that's called type definition. We can just type in the keyword type def in front of our structure object. And we can also then give it an alias. What type definition basically does, I'm just going to call it STC here. So instead of every time that we want to create a new structure, say we're going to be typing this a lot, instead of having to type all this text up, we can actually instead just reference its alias, STC. Again, we have to use the type definition keyword to enable this. So now I can simply come down here. Already had some code ready. You can create object of STC. We're going to name it S2. And we'll actually be able to reference our class the same as before. I'll leave the original one because we can actually reference it either way. Either original way or now with our new type definition. Let's go ahead and compile and run. As you can see, our original output unchanged. And our type definition output with some new variables, 33, 55, 498 point. Now, floating point messes up as you can see. I got 1, 2 and a little noise in here. We'll go cover that later on in a future video. But then our string text type def, as you can see. Alright, I think we covered C-style structures enough. But I did want to show that C++, built on the use of structures from C, and some of the terminology and convention in the use of structures stem more from this, and perhaps maintaining backward compatibility, at least in early programs, when programmers may have been migrating from C to C++. Okay, back in the realm of C++, I've gone ahead and created a structure as shown here. I've also listed a couple of definitions about structures here and their differences between the C language and C++. But unless you plan to code in C as well, which you surely can, for now we're just going to focus on the C++ functionality and not worry about them too much, except to realize they exist. In C++, we can also have member functions as well as data members, or variables. So this expands their usability quite a bit over just the C version. We can just scroll down and quickly run this for now. Do not worry about all this code in between. I've pre-prepared this lesson. Okay, here in main I've already prepared an object S of the type MyStructure. Notice in C++ we can omit the structure keyword. Down here we're initializing the data members again with the dot operator. To quickly demonstrate this, we can type s dot, and here we can see all the members that are publicly accessible. I'm just going to erase that, and I'll compile and run the code. Okay, as expected, our output pretty much matches the input. We've set data member 01 to value at 22, data member 02 to 222.22, data member 3 to the song number. And here we're just calling the member functions that print these out. Here we're setting the variables, and here's the functions. Scrolling back up, you can just see functions are simply just printing out the respective data members. Nothing special, just a quick demonstration of the structure. Okay, so enough for now about structures. Let's move on to classes. The reason I spent so much time on structures was for you to realize 2 points. One, that C structures and C++ structures have differences. And two, is that in C++, structures and classes are essentially identical, except for one small but very important detail. That is, by default, a structure is public, meaning all these data members are publicly accessible, where in a class by default is private, which means by default all of this is private information. I will explain this important concept more in a bit, but now let's just compare a class with our structure. As you may notice, I simply copied all the structure code and made it into a class. This is to help emphasize the similarity between classes and structures in C++. Let's drop down main again and adjust our code a bit and run the demonstration again using our class. I can simply change this line to my class S. This way I don't have to adjust anything else. I could have used C for the object name to avoid confusion, and I will in a second, but for right now I just wanted to demonstrate our class use. So if I compile and run it, notice we get the same output as with our structure, which is expected since the code is very much similar to our structure. I quickly just want to go back up to our class. I'm just going to delete the public statement. So now if you compare, except for the name, one's a class and one's a structure, the code is virtually identical. But now if I try to compile and run, you notice we get an error. And that error is because all of this data members are private, as you can see down here. So the key point to keep in mind is that in order to use a class, you have to make sure you use the public access specifier. I'll be compile and run. The program runs as before. And we can use private in MyStructure too. It's just basically the opposite. So instead of having to type public, if I type this private, I go back down to main. Change this back to structure. Compile and run. We get the same result, that error. Let's remove the private. Compile and run. So the main takeaway is in structures, all the member data is public by default, meaning you don't need any additional coding. However, in classes, all the data is private by default. So anything you want accessible publicly, you use a public keyword. So let me come back down to main and create a class. This time I'll call it C. Let me quickly copy and paste all this. Okay, compile and run quickly. Now we have our structure and class working side by side. So now that I've demonstrated that structures and classes in C++ are essentially identical, except for the data access specifier, where structure again is public by default and classes are private by default. I'm just going to go ahead and close the structure code, minimize it for now. So just a quick review of the material we went over. Classes are identical to structures in C++, except for the following list of key differences. A little joke here, exhaustive list. Structures default to public visibility and public inheritance. We'll cover inheritance more coming up, but the central takeaway, structures are public by default. By default, members of a class are private. This is an important concept to remember, as we've already covered up here. Classes in C++ are user-defined data types and contain data members and member functions. In functions and classes, variables are referred to as data members, and functions are referred to as member functions. This is just to differentiate that they're part of a class and not just a general variable or function. So when do we want to use a class versus a structure? The best practice guideline is use class if the class is an invariant, use struct if the data members can vary independently. Or, put more simply, if your class requires the use of one or more private members, use a class. Otherwise, use a struct. So if all your data is publicly accessible, use a structure. If you need at least one private member, use a class. So a quick review on the setup of a class. Again, we use the class keyword to specify we're creating a class. And we give it a name, in this case class name. Down here, my class. The convention is to capitalize the first letters of a class name to help distinguish it from other data types in code. So an example, I capitalize my and the C in class. I'm calling this my class for now. I usually use much more descriptive names in my programs, but for these tutorials, I think these names will help you follow along what is referencing what, in this case, a class. So at least for some of these early videos, I'm sometimes bending the rules of standard convention in order to help emphasize certain points. You'll probably notice as we go on, I'll start to migrate to a more formalized naming scheme once I feel my viewers are more comfortable with the core concepts. So returning to the class, first we have 3 variables, usually referred to as data members. These are followed by 3 member functions. As you can see, they simply print out the value in the data members above, as shown earlier. The last thing I want to point out is a class is terminated with a semicolon. This little detail often gets overlooked and can cause grief. Okay, I'm going to close or minimize the my class for now so we can move on to the next example, car 1. Also, don't worry about trying to read all this, as I'll make all this code available online. So again, we use the keyword class, and we're naming this class car 1. Notice now I have 3 variables above public. These are private and only accessible from within the class itself. They're basically private except for the class. It is normally good practice to explicitly state the access modifiers, but for now I just want to drive home the point that classes use private access specifiers by default. Underneath these I have a public access specifier. Everything under public will then, of course, be publicly visible. So in this class, I have 3 variables, or data members, that are private, and I have 7 functions that are public. Quickly going back up to the private section of the class, notice I have named these with a trailing underscore. There's mixed feelings on this in the community, but I think it helps make it clear in the code that these are private members. So while not necessarily convention, I do like to use them. Back in the public section, the first 6 functions I have made are in just 1 line each. For the first one, I am simply creating a getMake function of type string that takes no parameters, but returns the value of our private member, make. You're probably wondering why we go to all this work. It could have just made make public to begin with, and it would indeed work if we did that. But bear with me for now. As we progress, you'll begin to see the logic behind it. You may also notice that I'm using unsigned in my getYear function. Unsigned is simply short for unsigned integer. You can drop the int when using it for integer. For other data types such as long, you'll still need to type out unsigned long, but for integer, it's just a shortcut way to type it. It is somewhat convention to keep simple return functions, more commonly referred to as getters, which I will go over in a moment, on one line to avoid cluttering up the code too much. As you notice here, like our typical function, we have the brackets, and normally we would space them out like shown down here. I'll explain the difference why. But basically, since we're just having a simple return statement, it makes it cleaner, and at a quick glance I can tell what this function is doing. Just simply returning the value of the private member make. I also have 3 one-line setters, which as you may guess, will be used to set the value of the private variables. They take a parameter and then set the related private member to the received value. Again, with a simple set or assignment type function, it is convention to keep it on one line. And just a quick side note before moving on, setters and getters, yes, get used to these terms as we will be using them a lot, are also referred to as mutators and accessors. They're the exact same thing, just different terminology. Mutators mutate or change something, in this case, the value of a data member. An accessor accesses the data, the same as a getter. I like the setter getter terminology. Back to the class. The last function, details, is also of type string. Notice I created this function similar to how we've been using functions in our programs up to this point, with the curly braces containing the body of the function on separate lines. Since the details function is doing a bit more than just a simple return, I like to use a more traditional format to show it's a more involved function. In this case, we are forming a string by concatenating our private data members. Notice as well, we need to convert the unsigned year member to a string first before we can concatenate it into our string that will be returned. And it probably goes without saying that these simple exercises are just that, simplified, as more real programs often have much more complicated functions, thus why the difference in formatting can be useful. So I could have just as easily put the simple details function all in one line. Again, it's more to denote it as doing something more than a simple return a variable value type of operation. Let's move on down to main so we can interact with it. Went ahead and cleared out the old code and implemented some new code to demonstrate our car1 class. Okay, so first we've created an object car from the car1 class. Below that, I'm invoking our setter member functions to set the make, model, and year of a car. Then I'm simply printing out the details using our details getter function. Compile and run it. Nothing too fancy, but spitting out our 2019 Toyota Camry. Okay, so I hope this all makes sense so far, as I will now move to a slightly more complex class example. So pretty much using the same car concept as before, I've added a few more members, notably from a car dealership perspective. We have some variables or data members that we want to keep private and others we want public. Some examples of private are like the VIN, the purchase order, right, the dealer cost, dealer markup, manufacturer's rebate. And public's pretty much the same ones we had before, except I've added mileage and retail price. Again, this is just an example class, so don't actually code like this. But let's say we use the same class from a dealer backend program, where some information is skipped hidden from the customer, and also web front end, where we want other information to be accessible to the public. So things like perhaps the VIN, which means vehicle identification number, in case you didn't know, the dealer's purchase order number, which maybe is from when they bought the car from the manufacturer. We also have dealer cost, markup, and manufacturer's rebate, which may or may not apply, maybe depending on sales quotas or something. Those items we probably would not want to accidentally leak out to our public website. The next section, Public, contains the data members that both the dealer and the public website can have access to. Things like make, model, mileage, year, and retail price. We then have 3 getters, again to access the private members. Notice, we do not need to use getters to access the public visible data, as we can query that information directly. Then we have 3 setters. Again, for setting the values of our private data members. Do note, though, that I'm kind of relating these functions to data security, but I don't want you to get the impression that this is what the private access specifier is for. It works in this example to help give you an analogy, but we could simply want to maybe keep data members private to help ensure their validity. For example, dealers don't necessarily hide their car VINs from the public. Oftentimes they're listed on the website. But we might still want to keep it a private data member so we can ensure some type of checking or validation is applied when setting it. As shown in the class, the setVIN function checks to see if the VIN is exactly 17 characters long, which is the case for vehicles manufactured since 1981. And in case you were wondering, yes, I did need to look that up. And no, I am not a car dealer. If the VIN length check fails, it displays a warning to indicate this. In a real program, this would of course be much more functional, but for our example, it works fine. Then we have 2 more standard setters, as noted by the simple one-line format. Now back down into main, I've already added some code to help demonstrate the car2 class. Again, we're creating an object, this time C2, derived from the car2 class. Next, we're setting the publicly accessible variables or data members directly. In this case, C2, our object, setting the make, the Honda, model, the Accord, year 2019, and retail price $28,000, much as we did before. And here we're setting the private info. You need to use setters getters to access or change these values. So I'm using the function setVIN, setPO, and set wholesale value, basically what the dealer gets the car for. And notice I'm setting all this data by using the dot operator. For example, if I type C2 dot, the IDE automatically shows all the data members of the class. Notice also that the IDE shows the private members, but they're marked red, meaning they're not accessible. Just to be clear of what's happening here, we're using these setters and getters to set our private variables within our class. Let's go back up quickly. And we can see that the setter void setVIN is going to input the VIN number, do a basic validity check to make sure it's length of 17. If it checks out, it's going to set private member VIN to V. Same thing with our setPO and setWholesale. We're just basically, in this case, assigning the input of our function to the private data members. Since these functions are part of the class, they have access to these data members. Anything outside the class does not. That is why we have to use setters and getters to interact with these private data members. I hope that makes sense. Okay, let's go down in main. At the end, I just have a couple of output statements. Again, accessing the information directly, either by the data members themselves, or if it's a private data member, we can call the functions, the getters, to get that information for us. Let's go ahead and compile and run this. Okay, I had a slight typo down here. Let me compile and run it again. Alright, as we can see, we get a little bit more information now out of our new class object. So as before, we're returning the 2019 Honda Accord. This time we're also returning the price, retail of $28,000. Then we also have a second line of information that maybe is just available to the salesman. We have the PO, the VIN number of the vehicle, and what the dealer cost is. And you might want this information, because buyers are going to negotiate down from this number, and the dealer, of course, will be negotiating up for this number. Most likely won't be selling you the car for this. They might be lucky and meet somewhere in between. But I have one more example. This time I just made the car class. As you can see, this is just an expansion of car 2 with a lot more data members and a few more functions. In case you are wondering, I kind of went backwards with the naming, saving the car class name for last, as I think I'll be using this class in another video to expand upon our knowledge of classes, as there is much more to learn than I can cover in just one video. In the private section of our class, I've created several data members. You may notice the last 3 use all caps in their names. This breaks from our trailing underline naming scheme and means these names are referring to constants that once set should not change for the duration of the program. So unlike the other private data members that we can use setters with, these are set once and left alone, thus the all caps naming to help indicate this. In the public section, we have a bunch more data members or variables, followed by a series of setters and getters. So far, except for more data members and functions, it is for the most part a scaled up version of the previous class we looked at. Where it is going to be different though, is this next part under the class. These 3 functions are actually car class functions. However, their code is external to the class itself. Note above, we actually declared these functions earlier with just prototypes. If you remember back in our earlier lessons how we prototype functions at the top of the main, and we put the actual function itself underneath main, it's the same concept here. We need to prototype it within the class body itself, but we can actually define the function outside of the class. This can help keep an otherwise large class a bit cleaner to read and maintain, and also allows modification of a specific function without necessarily breaking the class in doing so. Once again, notice that we have some basic data validation in our external functions. Note also that we're using the scope resolution operator with these, as we are not referencing an object, but members of the class itself. Hopefully you remember the scope resolution operator and its usage from the last video, along with the concepts of scope. Well, this is the point where that knowledge comes directly into play. If you haven't seen the video, or you don't remember anything about scopes, blocks, or how the scope resolution operator works, now would be a good time to go back and review it. So if you do remember all that stuff, you can see with the first example, car : set VIN, we are referencing the set VIN function within the class named car, and not simply creating a new function out of thin air. Following the set VIN prototype we declared up in the class, the function needs to return void and accept a string as a parameter. Here I'm simply using VIN as a string lowercase vin. Inside the set year, pretty much the same. We're accepting unsigned and set year and set few. And down the actual function definition, you can see we're using a Y to accept the input. Doing just a real basic check. And if it checks out, we're setting the value of Y to the private member year. If not, it's just a real simple output statement. Again, this is a real program. The validation would be much more complex, but that works for our purposes in this simple program. Also note the set year function, we're using our constants that I declared above, year min and year max. Those we actually hard-coded within the class itself. Note that I'm using a range of 1960 to 2025. Depending on the fictional dealership preferences, they might only deal in newer cars, so the range could be much tighter. Maybe we only go to year 2000. Also note that you'd have to periodically update the year max variable, as new car models are constantly introduced year after year. The set fuel function is a bit different, and it takes an integer for fuel type, 1 through 6, and queries an array to return the string value of a fuel type. This is just an example of how we could introduce more complexity to the input validation. Don't worry too much about this yet, as we haven't gone over arrays yet, but it allows the person adding new car information to simply pick from a list of fuel types instead of worrying about typing out the exact name of the fuel. Again, don't get too hung up on the implementation of this function right now. The takeaway I want you to have is that we can use these functions to incorporate a variety of ways to validate the data before assigning it to our data members. So once we start to get a real complicated data validation function spanning many lines, you can see why we wouldn't want all these functions clogging up our class code and why we may instead want to keep them outside the class. Now the next 3 lines of code are simply an example of how we can initialize some of the class values outside of the class. Again, note the use of the scope resolution operator, so we are referencing the members of the car class. You would only want to do this with data that is either a constant or will not be changing among different objects created from the class. These 3 are good examples, as fuel types, as described earlier, probably don't change too often, at least not on a day-to-day or week-to-week basis. Also, dealer markup and possibly any rebates might be static, at least for a month or so. Again, these are just examples and will work fine for our purpose. Under this is another function we would use to set the fuel type, as mentioned earlier. For this, imagine someone sitting all day keying in the new car inventory. For many inputs, you'd want simple drop-downs or something similar. Anyway, this is a way we can input a single integer representing a fuel type. This function is not part of the class and is a standalone function. Let's drop back down to main. I've gone ahead and input some code I previously wrote to make the video a little bit shorter. Again, we have our class name car, so we're making an object C of the car class. The following lines of code are publicly accessible, so we can access the member variables directly. As before, Honda Accord 2019 retail price. Private info, as before, we need to actually call setters and use the functions to input the data into the data members of the class. And down below, we got some output again. Again, the public car information is usually directly accessible. The salesman information is accessible through the getter functions. So let me compile and run this. And hopefully it works, and it does. Okay, as you can see here, much like before, we have the car info. 2019 Honda Accord, retail $28,000, fuel type gasoline. And here's information maybe visible for the salesman. Purchase order number, the VIN, dealer cost, just as before. But here's maybe some information the sale manager might be interested in, like what the actual wholesale cost of the car was, any manufacturer's rebates that are available, and the minimum amount of markup they need, or basically this covers their costs of just selling the car, preparing it, ordering it, paying salesmen and the like. I'm not a car dealer, so I'm just making this up, but just for an example here. And down here is just some financials. Like here, the absolute minimum price they might want to sell their car at, counting all this, is $22,200. That's simply, again, the break even. They probably wouldn't sell you the car at this price, but that's just kind of a number they can look at and say, you know, this would be the absolute bottom just for us to break even. So we definitely want to get more than this. And here also just created some example sales outcomes. This is just created basically in the output code here. And just showing kind of like the profit margin at various levels. So 0%, their break-even thing. Of course, they make $0 and the salesman will make $0. So again, they probably would not want to sell at this. They want just a 25% profit. Sell it for $23,650. The dealer would make $1,015. The salesman might make $435 commission. At 50% profit, again, this is just profit off the sales margin, not the entire price of the car. The final sales price car would be $25,100. Dealer would make $2,030. The salesman might make $870, and so on, And they did sell it for full retail price. The dealer might make $4,060. Salesman get a nice $1,740 commission. And I just pulled these numbers out of air, so if you're a car dealer, feel free to laugh at me. It's more for the demonstration of our class program here than the inner workings of a car dealership. Okay, before moving on, I want to quickly demonstrate the set field type function I mentioned earlier. And I just have it commented out to use on the line here. We manually set it to 0 here. So I'll just swap these, comment this one out instead. I'll compile and run the program again. Okay, now the first thing you see is our set fuel menu app. So by default it's set to gasoline. But let's say we want to try a different fuel. Maybe it's a natural gas car. So hit 3 and hit enter. Then you can see here how we input the natural gas instead of gasoline. Then we go back up to the set field type function. Again, it's outside. This is not like these. These are actually class functions that exist outside, but they're using the scope resolution operator to reference that they're part of the car class, or that they're referencing the car class. But this is just our normal function that we've been using before. So set field type. So I do need to reference the class car, and I'm making the object S, so I can access any data that I need or interact with any data I need. We just create an integer ID, setting out the user prompt, few IDs and types, and we're just going through a little loop here. And since we only got 6 field types, we're just kind of running I through 6 here. That'll give us our 6 indexes. 1, set field to I, and for that we're running up here, we're calling, again, we made it object S of the class car. So we're calling set field from this S and feeding it the integer I. So if we actually go up to the set field function, we can say that we just got the prototype here. So it's one of our external class functions. So basically we're inputting it. The first run through the loop, we're going to feed I 0. 0 is less than 6, yes. We're going to fill on the field type, our private member field type, the value of field types from the array at index 0. And the array is down here in this line. We're setting the array field types. Index 0 is gasoline, index 2 is ethanol. Index 0 is gasoline, index 1 is ethanol. Index 2 is diesel, index 3 is natural gas, index 4 is propane, and index 5 will return electric. So in our example program, when we typed in 3, we're referencing index 3, which is natural gas. Basically, this loop is just going to display all the values. It's just going to loop through 6 and pull all the indexes, or all the values associated with each of the indexes, and display them so the user can pick from. Then I'll enter a prompt for the user, enter field ID. The user entered the ID. Here we're just calling a system clear screen to get rid of the menu when we return back to our main. And here we're returning the ID that the user gave us. So the main essence of this function is that we're just looping through to generate the menu of all the array objects that exist within the class. Then allow the user to input which field they want. Again, just think of this as something like somebody is going to input all the new car inventory. So we'd have many different ones of this, but I just want to demonstrate, there's different ways, you could go about interacting with classes and the data within it. And I think I covered that function enough. The last thing I'll just mention again, the system clear screen is just kind of more of a decorative thing. It clears the screen for us, but if you're running this on something other than Windows or with a different IDE, this could cause trouble. So feel free to just either comment that out or delete it. And also notice at the very top, I've included Windows H, and that's the only function within this entire program that requires that. So if you do want to just get rid of that, you don't need that header either. I think I spent enough time on that. So let's go down into the main function here. Going back to the code here towards the end. You can see we're getting most of the output directly from either the data members themselves or via the getters. This is actually what we want. But at the very bottom here, I'm actually doing some calculations within we're in this final output loop to generate that little table I showed you before. Yeah, I'll just run it again. Bigger code. For this little table to generate, that's what this loop's about here. And I've got some calculations you can see here to determine those profit percentages. So we want to minimize this if possible. So we could probably move any common operations into the class. And in case you're wondering, yes, I did leave this intentionally because I wanted to illustrate we want to keep our calculations and functions where possible because we may want to reuse it somewhere else. I'm mainly talking about the class data here, as we could indeed put the for loop into its own function too. But for now I'm concerned with just getting rid of the class member calculations where possible. So basically things like this here. So you notice there's actually 3 instances of this, so that's a perfect candidate for us to get rid of or move somewhere else. So you can see we're performing a min price subtraction from the C retail price 3 times. And since min price is actually derived from the get dealer cost function, which you can see here, so we could perform this math in the class itself instead of in the output loop. So why don't we call this new function something like max margin, since it will represent the maximum difference between the retail price and the dealer cost. Since we're referring to C retail price and C get dealer cost, we can put this calculation back into the class since they're all members of the class. Even min price, because as you reference here, it's actually C dealer cost. So let's go up to the class and make a new getter function. Okay, since this is a getter function, I'll just add it right at the end of our existing getters. And since we're returning a value, I'm just going to use the unsigned again. And we'll call this get max margin. And it will take no parameters. And since this is actually going to be doing a little bit of math instead of just like explained before, these are simply returning the values of the variables. But since this is actually going to perform some math, we'll actually format it in bracers like you're kind of used to now. And since it's a getter, we're going to be returning a value. So we'll start with a return statement. And we're going to want to get by the retail price, which again is the high end for our margin calculation. So that's the maximum amount that the dealer expects to get, or hopes to get, I should say. And from that, we're going to subtract the get dealer cost, the result from the get dealer cost function. And some of these are not covered or shown as examples down here. They're used within calculations, but on your own time, you can feel free to read through this and see how they basically interact with each other. But for now, this should work. So this should get us, again, what I'm looking for is just a margin here, simply to calculate their profits. This is just more of a exercise in displaying some useful, I guess, output for a dealer, more than it has anything to do with the actual class itself. But here, we're just going to return the margin. I think this looks good. Move down. And whenever I add something like that, I just like to test it real quick. So here, after we set everything, we'll just add a new standard out. And of course, it'd be type C, get, let's see, max margin, I called it. Okay, so again, I just added this line. I'm going to compile and run it. Yeah, I was going to uncomment that, but all right. So what I'm looking for here, nothing fancy, but I just wanted to make sure that our get max margin worked. And here's the 5800 here. So that's working as expected. That's all I wanted to do for now. And I'm thinking of it, just comment out that menu. You've seen that already. And I'll copy this, but we don't need, let's get rid of this line here. Okay, so now since we incorporated this functionality within the class, we can simply replace this. I'll just delete it here and paste it in with a get margin function call. And also, since we're actually not performing a math function, I can remove one set of parentheses here. I do like to keep all math functions in parentheses, as you notice. And also here, let's get rid of that. And get rid of the parentheses. And before I change too much, I just want to compile and run again. And sure enough, let's see here. Let's see, it looks like when I copy paste it, cut off the C for a car class or C object, part of the card class. Okay, let's compile and run again. There we go. Looks like the functionality is restored, and it's pretty much like the same results as before. So we got rid of some of the math in the output and instead put that up in the class where it belongs. I mean, that's one of the whole purposes of class, is to provide that functionality kind of behind the scenes where the users can just access what they need out of it. And let's see, we can also, looks like we're only using this min price now in one other place. And since it's basically just getting its value from the get dealer cost function here. Just copy that whole thing, grab the C this time. Alright, copy. And I'll just replace the min price with that function. Leave that temporary. Compile and run. Add an errant semicolon. Compile and run again. And it looks like we're still good. So it looks like pretty much the same results as before. We can go ahead and get rid of that line too. Okay, I didn't mean to spend so much time here at the end formatting our output, but the main takeaway I wanted you to leave with is, try to avoid doing any of that, especially class mathematics. If all the data members are part of the class, put them up in the class where they belong. So the only thing we're left with now is we're either accessing the data members directly or calling on the getter functions, which is perfectly fine. We are doing a little bit of math, but mainly that's just part of the loop here. Is actually, we're just taking the iteration here. We're going through 4 times to make a little chart, and multiplying that by like 25 to equate to 25%. So we're basically looking at a 0, 25% profit, 50% profit, 75%, 100% profit, like you've seen in the chart here. So that's where that comes from. And I did spot up here. Looks like we could probably, maybe we could do something with that. But since there's only one instance, I'm going to leave that for now. This video is getting long enough. And hopefully you can see, what I'm trying to accomplish with that. Okay, so that's about all we can do as far as class data for now. The remaining output code could be further optimized. But as I said, I wanted to mainly go over class operations in this video. I think we have covered quite a bit of ground today, and I also think I'm going to be using this car class in another video, as I think it will work out well for some further topics concerning classes. Wasn't my original intent, but the more I worked with it, the more I started getting ideas for what we could do in the future. I mean, there's constructors, deconstructors, external files. I think that'd be a good maybe little side project that we can work on. And I think it does relate into the real world rather well, at least. I know to me it makes more sense than just, doing functions that perform no real purpose. Well, this doesn't either. At least you can kind of imagine maybe it work in the back end of a dealership or something. Again, that's it for now. The next video, we're going to slow it down a bit. We're still continuing to work with classes, but I'm just going to show you how to create a class again from fresh, add in a function that we've used before. But the main concept of that video, we're just going to take that new class and move it into its own separate files, which will consist of a source file and a header file. So instead of covering a lot of new concepts like we've done in these last two videos, next lessons could be a more practical approach or a how-to video, which will be helpful for upcoming portfolio project that I've yet want to get to. So that's it for now, and see you in the next video.